In this session here, we're going to be taking a look at integers. Up until this point so far in our teaching sessions, we've been dealing only with positive numbers. A new concept perhaps for many of you that is foundational within algebra itself is the concept of negative numbers. Now at first it may be a little bit difficult to grasp because we are so used to using numbers to count things. Rockets, apples, oranges, the amount of time that we've traveled, how many miles we still have to go, and so on. So the concept of having -3 apples is somewhat confusing. Therefore, we've kind of perhaps bought into the notion that there is no such thing as negative numbers. However, numbers can also be used to do more things than simply count. Uh, with that said, numbers can also be used to tell you where you are in relationship to a particular reference point. And what I like to do here is to give you just a couple of everyday examples of where we use negative numbers all the time. First of all is our temperature scale. In Fahrenheit, the freezing point of water is 32 degrees Fahrenheit. But if you live in a colder section of our country in the wintertime, frequently the temperature gets to below zero on the Fahrenheit scale. You can have 10 degrees below zero. You can have 7 degrees below zero. You can have minus 15 degrees. You can have minus 60 degrees. So there's a common everyday example of negative numbers. You can also have negative numbers, for example, in relating how far below sea level particular pieces of land are. For example, the Dead Sea in Israel or Death Valley, California. Both of those locations have uh, depths, or I should say elevations, that are below sea level. And the way that you would represent that would be something to the effect of minus 270 feet. And that would be the elevation beneath sea level. The positive values describing those land areas that are above sea level, and those that are below sea level would be referenced with a negative number. So negative numbers do in fact exist. Now, if we were to take a look at a number line here, here's a typical number line. Here's 0, our starting point, our reference point. And the method that they have chosen to use for horizontal number lines is that the smaller numbers are toward the left and the bigger numbers are toward the right. Well, for a moment here, let's just start at the number 0. Using that analogy, is 3 greater than 0 or less than 0? And I'm going to say here plus 3. Well, it's greater than 0 because it's further to the right on the number line than the number 0 is. What about 5 and 1? Is 5 greater than 1? Is plus 5 greater than plus 1? Or positive 5 greater than positive 1? Well, yeah, we have no problem with that. But if you were to just try to answer that question with the number line, you could also show that plus 5 is greater than plus 1 because plus 5 is further to the right on the number line than plus 1 is. Well, now let's take a look at what goes on to the left of 0. To the left of 0, the numbers get further and further away from 0. And what we do on the left-hand side is we count just the way we do to the right-hand side, except that our sign for each of our numbers here will be a negative instead of a positive. So what's the first slash, our first number to the right of 0? Plus 1. What's our second number to the right? Plus 2. Our third number, plus 3. In the same manner, our first number to the left of 0 would be minus 1. Our second number would be minus 2. Our third number, minus 3. Our fourth number, minus 4, minus 5, and so on, going left. So with that said now, let's ask ourselves the following questions. Let me go ahead and just stick a couple of points here in blue. We have that point there, that point, this point, this point, and this point. Okay, my question here, well, let's just go ahead and make it a little bit more simple. I'm going to go ahead and label each of these points using a different letter. So starting at the left, our first point is point A, and then all the way to the right, our fifth point in blue is point E. So let's take a look. B and A. Which of these two numbers is bigger, is larger? And be careful. It may not be quite what you think to start with. Remember, on our number line, the numbers that are further to the right are bigger than the numbers that are further to the left. So you have to ask yourself the question, is B or A further to the right on the number line? Well, B is. That means that B is bigger or larger than A. Well, what is the coordinate for B? -3. -3 is bigger than -5. Let's go ahead and take a look here at D and E. Which number's bigger? Well, the coordinate for point D would be +1, +1, and the coordinate for point E would be +4 or +4. Which of those two is greater? Well, the +4 is, because it's further to the right on the number line than D is, +1. Okay, let's compare D with B. Which of those two numbers is larger? Well, D is +1 and B is -3. +1 is greater than -3 because it's further to the right on the number line. And if it helps you to think of temperature, which is warmer, +1 degrees or -3 degrees? Which is greater, +1 degrees or -3 degrees? Well, +1 degrees is greater than -3 degrees. So we have a category of numbers, whole numbers, called integers. And basically integers you can think of them as being counting numbers. 1, 2, 3, 4, 5, 11, 17, 28, 38, 109. All of those are counting numbers. Well, up to this point, most of the counting numbers we've always assumed to be positive. And they have been. But there are also negative numbers. And if you want to think of them as counting numbers, or I shouldn't say counting whole numbers, negative whole numbers, you also have a -1, a -2, -3, -4, -5, and so on. So we can see that our integers is broken into actually 3 types of categories. You have your positive integers, which are your whole numbers or your counting numbers greater than 0. You have negative integers, which are the whole numbers less than 0. And then you also have 0 itself. 0 is neither positive nor negative, but it is an integer as well. And what do I mean by a whole number when I say a whole number greater than 0? I mean a number that's not a fraction and that's not a decimal. Okay, that's the concept then of integers. Positive integers, negative integers, using the number line. The number that's further to the right is larger than that which is further to the left. Okay. That is your review. Integers are whole numbers, not decimals or fractions. They can be greater than 0, which would mean that they're positive integers. They can be less than 0, which would make them negative integers, or they could be 0 itself. And then once again, horizontal number line, the smaller numbers are toward the left, and the larger numbers are toward the right. That'll finish session 17 on integers.